Welcome back, guys. So, in Pully constraints, I'm going to discuss about constraint relation. So, in constraint relation, we'll get the relation between other relations. First of all, this is a constraint equation. So, already in previous video, I discussed about constraint is nothing but resisting the motion as they want to move. That means, so there's a restriction to the motion of them. And here, the number of equation and number of variables. So, if you see these diagrams, so tension, accelerations of 1 and acceleration of 2 are variables. So, here acceleration of A, B, and C are variable. Tension, 4 variables are there. 3 variables are there. But from this diagram, we'll get only 2 equations. So, here 3 equations I will get. 3 free body diagram equations I will get. But 4 variables are there. So, to solve that fourth equation I want, that is the fourth equation is constraint equation. So, that is relation between accelerations. So, to get relation between accelerations here, I will follow. One is work done by the tension is zero method, work done by tension method. So, work done by tension method is very easy and appropriate method. So, we'll follow this only. Coming into next one, displacement method. And displacement of the pulley based on displacement. Third one, segment method. Fourth one, shortcut method or pulley and block motion. So, this is we are going to discuss. So, for easy one, see once. So, here in our constraint equation, the first consideration in all the problems is that the friction between pulley and strings is 0. No friction. So, tension is same everywhere. Tension in a string is same everywhere. And strings are inextensible. Strings are inextensible. So, these are the main consideration in constraints are in NLM also. Now, if you see, first method tension, work done by the tension is 0 here. So, work done equal to, we know, force into displacement actually. But here the derivation of the displacement will give acceleration. So, directly we'll write T into acceleration is equal to 0. So, a small example here. So, this is A block and B block. And remember this point. You can consider the acceleration direction in your which direction. You are in which direction you can give the acceleration. So, after solving, so acceleration is coming negative. Then direction is opposite. Direction is opposite. So, here see I have taken A2 is downwards and A1 is upward. But you can consider A2 and A1 are different direction, you can consider, not a problem at all. But you will get answers are same. That I'll give here. So, now here 2T and accelerations both are in the same direction. So, work done is positive. 2T into A1 means acceleration of A. So, here T and accelerations are opposite direction, therefore negative. Negative T into A2 is equal to 0. So, therefore, A2, TT get cancelled, 0. Now, this right hand side 0, therefore, TT can be 0. And A2 is equal to A1. So, if you take accelerations are opposite direction also, you will get same. That means see 2T into A1 negative plus T into A2 is equal to 0. Then A2 is equal to 2A1. So, this is the relation between A2 and A1 by tension. So, this is method 1. The same method apart to the second diagram. So, to the second diagram also same I will apply. See once. So, for second diagram. So, if you see clearly in second diagram, apart anyone, so B is moving down, A is moving up. That means AB is, so here AB is downwards and AA is upwards. So in the string of AB where the B mass is there will be T. Then T into AB is equal to 2T into AA. So T get cancelled. Actually, the work done, total work done equal to 0. That I am taking anyhow equal to have to take. So therefore, AB is equal to 2AA. So this is from the work done method. Third one. So in the third diagram, so B is moving downwards. Consider the B is moving downwards. This is aberration of B that equal to. So B is moving downwards, and I will take AC means A3 is upwards. As same way A1 is also upward. I will take. And consider here this is the T1. So this is string also T1. T1 is pulling. T1 and a T1. On the blocks, T1 is pulling force. On the pulley also it is T1 pulling force. Therefore, according to work done by the tension method, so now T into A1 positive work done plus. See here this is T1 T1. So in this string, second string, the tension is 2T1. That equal to T2. So as 2T1. So you can go with T2 into A2 or 2T1. Therefore, minus of here work done minus 2T1 into A2 because A2 and displacement and force are opposite direction. Work done is equal to negative. We know it is a scalar quantity. Fs cos theta. 180 means minus. That is already plus T1 into A3 is equal to 0. So all T1s get cancelled. So therefore, A1 plus A3 is equal to 2A2. This is the final equation between means constraint equation which is giving the acceleration reactions. So now we'll see another method 2 which is giving means remaining method. All methods I will explain: segment method, displacement method, and pulley and block motion method. For first one diagram I will take. For that all three methods and we'll getting the same answer or not, we'll see. So here the length displacement you have to take from fixed pulley alone. I have to take fixed pulley to the blocks and mobile pulley. So from the fixed pulley, first block is in the x1 distance, and pulley in the x of the pulley I can take here, and second block in the x2 distance, and this third string is in the x3 distance. So remember in the displacement method, the displacement you have to measure from fixed pulley to the blocks and mobile pulleys. So from this first L1, length of the first string is equal to, so here x1 plus x of the pulley. So double derivating 0. So a1 plus a of the pulley. Therefore a1 is equal to minus acceleration of the pulley will get. This is equation 1. So if you see here acceleration of the pulley is moving down. So the string is inextensible. So the total length, this length and this length will be released this side. That's what 2xp. The block of this one will come 2xp. We will see that. So now here next length 2. The length 2 is equal to. So here this is x3 minus xp. From the diagram, this is x3 minus xp plus. So this length is x2 minus xp. So here, so x2 minus xp. So that is equal to x3 plus x2 minus 2xp. So here x3 also invariable constant because it is fixed. X3 also. Therefore L2 is constant. 0 is equal to 0 plus. So A2 minus 2AP. Therefore A2 is equal to 2AP. Then acceleration of the pulley is equal to A2 by 2. So this is substitute in the first equation means in A1. So here that you will get 2A1 is equal to A2. 2A1 equal to A2. So in first tension method also same equation comes. A2 equal to A1 for first case. Method 1 also same. And method 2 also same. So now in method 3, so about first diagram I will explain the, means this case all methods I will explain. So now in method 3 we will go with segment method. Segment methods. In segment method we must remember that the length of the string is decreasing, I have to take minus sign. And the length increasing in the case, length is extending, increasing nothing but extending, then plus we will take. So in problem why this concept I have given, you will understand. So this is very important, remember. In the segment method means here this is one segment. In the diagram, this is one segment. Segment 1. So this is another segment, segment 2, segment 3, segment 4, 4 segments. So for segment 1, so first of all L1, segment 1. So here points you consider 2 points. You take here 2 points here, A and B or P and Q. So here A1 means this A1 is moving, one is moving upwards, that is the other reason we have considered already. In all the cases, A1 is moving upwards. So length is decreasing. And this point is A is not moving, therefore 0. That equal to segment 1 delta L1 L1. Delta L1, change in length of segment 1, that is equal to minus XA. So now in the segment 2 delta L2, increasing, that is right. Delta L2, that equal to plus XP. So total length of the segment 1 is equal to delta L1 plus delta L2. This is delta L1 or delta L2 are change in length. So these are change in length. So XP minus XA. So derivation of this total length will be 0. That equal to AP is equal to AA. A1 is equal to AP. So this is C. Same equation. Now in the segment 3. So coming into segment 3. So segment 3, that means the pulley is moving down here. Pulley is displacing. So segment 3 is no length, right? So delta L3. So segment 3 is also decreasing, right? Pulley is coming down nearer to the ground. So that is X3 minus X3. Delta L4 is equal to minus X. So I can go with the delta L4 is equal to minus X2 or X4. That is your wish. So now total length is equal to this X3 plus X4 are same here. So the pulley how much is moving, that the same will come. Therefore, so in shortcut method this will understand clearly again. Therefore delta L3 plus delta L4. So that is equal to here XP. So that is equal to X3 plus X4 into minus. So here if you see delta X3 is equal to XP. Means here delta X3 how much XP is moving down. In X3 also decreases that much. Minus X3 is equal to minus XP. And delta X4 is equal to, so if you take string here, this is the point 2 and here pulley. So now point 2 is moving, so extending this is, means this is increasing the length. Therefore this is X4 positive. And pulley is moving like this, the length is decreasing. This the segment 4 length is decreasing, pulley moves means that equal to minus XP. Therefore delta L4 equal to plus X4 minus XP. So minus X3 minus X3 is equal to minus XP decreasing. So here, so 2 XP, this is 2 minus 2 XP plus X4. The total length of segment 2 here. So once again, so this is the segment 4. In the segment 4, P point means pulley is moving down, then it will be decreases length, and B is moving down, so X4 increasing. This represents increasing, this represents decreasing, P. So that's why the segment 4 length is equal to X4 minus XP. This is the length present. Now in X3, the pulley displacement is decreased. So segment delta L3 present is equal to minus x3. So this is, so now this total length minus 2 AP is equal to, means plus 2 AP is equal to A2. So now AP is equal to A2 by 2. So that implies again, see AP is equal to A2 by 2 came. So finally you will get the same answer, that is, so from this again we will get AP we are substituting, means A2 is equal to 2A1. Here A1 and A is same. So I hope you understand. So this is the method 3. So in shortcut method, so that is motion of pulleys. So that is, see, in shortcut method here. So this is the pulley. So the pulley is moving downwards, and here is the third point, and here is the second point. So now shortcut method is equal to x of the pulley is equal to, so this is not moving, so 0 plus x2 in the same direction of motion of the pulley, that equal to x2 by 2. x2 and x3 direction I have to check, then x2 is equal to 2 into xp in shortcut method. So x2 is equal to 2x2 by 2, means x2 is equal to xp. So for pulley 2 this is for pulley 2. Now consider pulley 1. Pulley 1 is fixed here. So this side there is a xp down, and black 1 is there here, right? So a1. So this x2 is equal to xp, means a2 is equal to 2ap. ap is equal to a2 by 2 again, right? So now here see it is 0. 0 is equal to, so a1 is upwards, xp is downwards, xp minus a1 by 2. So that equal to xp, means ap is equal to a1. So this is shortcut method, means application of shortcut. In the same way here, see one more method. So the shortcut method only how to apply here means, so this means we will apply the displacement of movable pulley. So how much the second pulley is moving, means movable pulley, so much down it will be, means how we will take it is, I'll explain, you know, 1 minute. If you know, so diagram here, this is the one fixed, so now pulley connected like this. So now the pulley is moving x displacement here, pulley is moving xp. So this is x, means a to b, and here c to d, and we know this is constant. So now here the pulley is coming here, then ab plus cd displacement is equal to displacement of a2 second one. Displacement of second one is equal to ab plus cd. So that equal to 2 into xp is equal to acceleration of 2. So equation will, now here this is acceleration of 1, and this is acceleration of, means displacement of pulley and displacement of black one, x1 equal to xp. So that is clear. So this is shortcut method only, but like this will follow. So here one more I will explain, one more diagram I will explain in pulley constraints, you will understand clearly. Then we will go for example problems in next video, because it is extending more time now. So the diagram is like this now. So these two are the fixed pulleys connected to a movable pulley. So another string, block of mass 2, second pull, second mass. So now this is also fixed pulley. Pulleys are fixed to the wall, and here black 3 is there here, and here black 1 is there. So we'll go to displacement method. First of all, method 1, this tension method here. So already tension method is completed. So these two are the strings are different. This is the string is 1, this is the string is 2. So this total is string 1. So this is string 2. So now in the tension method it is easy. So again I am writing here, see, first method 1 tension. In the tension method T into you give the aberrations. So this is aberration A1 and you can go with A3 like this, no problem, upwards, and A2 downwards. That is your wish. So now T1. So here is the pulling tension on the black T1. This is here also same T1. So now this is 2T2. So now T1 into A1, both are upwards I have taken, plus T2 into A3, T1 into A3 is equal to 2T1 into that equal T2, 2T1 into A2. So this is negative work done and these two are positive work done. So equal to have taken T1, T1 get cancelled. So now 2 A2 is equal to A1 plus A3. This is the constraint equation between aberrations according to tension method. What is that? 2A2 is equal to A1 plus A3. If any one direction is differently have taken, means A3 is downwards and A2 is upwards. So then you will get 2A2 is equal to A1 minus A3 or A3 minus A1 like that, directions. So these are vectors. 2A2 bar is equal to A1 bar plus A3 bar, like that vectors again. It is better to understand easily. So this is in method 1. So now coming into method 2. So that is displacement method. So displacement you have to consider from fixed points. So these are fixed pulley is to blacks. So now fixed pulley is to black. This is first x1. Next x of the pulley. So some differently you take x of the pulley, this is, and here x3 and this is x2. So I hope you understand from the fixed pulleys to all the blacks and mobile pulleys displacement I have considered. From this I'll get now equation like this. So length of the string 1 L1 is equal to x1 plus, so this is x2 minus 2 into x2 minus xp. Oh sorry, 2xp, x2 is not there, 2xp. From here to here I have taken xp. So no problem, 2 into xp and plus x3. So now 0 derivation a1 plus a3 plus 2 ap. So here ap is equal to a2, right? So we will get that is also will get, we'll check. So now 2 ap is equal to minus of a1 plus a3, means the ap direction is opposite to a1 and a3. So a2 means ap is equal to a2 you have to prove, then a2 direction is opposite to a1 a3. So you will consider. So now segment 2 L2. So L2 is equal to, how I will get L2 length? So that is x2, L2 is equal to x2 minus xp. So derivation, see, this is L2, right? Therefore x2 minus xp. So derivation of this one, we will get v2 minus vp, that is double derivation x2 minus xp. So a2 minus a. So that implies a2 is equal to a. The direction of bar is equal to a2 bar equal to ap bar. So those two are in the same direction. Now you can go with 2a2 is equal to a1 bar plus a3 bar. So same displacement. So coming into method 3. So in this method 3, so no segment method. So this is segment 1. So here segment 2, segment 3, and this is segment 4, right? So here segment 1, 2. So this is also 2 only will come. This is 3, this 4. I'll take like this. So now in the delta L1 first, delta L1 is equal to first segment decreasing, therefore minus x1 or xa. Delta L2. So both are decreasing, right? These points are moving up. So both are decreasing. So these points So now these two are moving up means okay, these two are coming down. These are pulley is coming down. So now increasing. Therefore minus plus minus not 2xp. Delta L3 segment 3. So total length I want to get means length of the string 1 is equal to delta L1 delta 2 delta L2 plus L3, that is delta L3, that is equal to L1 total length of the string first. So now here L3 also decreasing, that is equal to minus x3. So therefore total length L1 is equal to delta L1 minus x1 minus x3 plus 2 xp. So that implies, so already here I have taken A1 A2 directions are negative and pulley is opposite direction. So directly I will get directions are exactly correct. So here 2 AP minus of A1 A3, that means the acceleration of the pulley is opposite to A1 A2. I got it. So here also same. The acceleration of the pulley, here I have taken pulley in downward direction. So that is equal to acceleration of the pulley in downward direction is equal to acceleration of A1 A2 upward direction. Therefore acceleration of AP2 AP is equal to A1 plus A3. So first equation over. So from the segment method. Now segment 4. For segment 4 only delta L4, that equal to L2. So that equal to L2 segment 4 means it is increasing now. So that here AP also there, AP is decreasing and A2 is increasing, that equal to x2 plus x2 minus xp. So this already I have given in the previous problem. So like this you have to take. This is point 2 and the point of the pulley. The pulley is moving like this direction, decreasing. The length is increasing. O2 is moving like this direction, increasing. Therefore, derivation 0 is equal to A2 minus AP. Then A2 is equal to AP. So this is answer. So now method 3, shortcut method, method 4. So shortcut method I will give finally. Now see if you see. So this XP and XP are moving downwards, right? So now these points here, points A and point B consider on the diagram, in the diagram. A and B. So here C and D. So now AC and AD. So that is the motion, right? So that equal to, so these two lengths, it is coming, pulley is coming here. The two lengths are equal to the, means here x of the pulley is equal to A2, we know already. Means A of the pulley is equal to A2. So now see, so here these two lengths, decreasing these two, increasing these two length is equal to decreasing in these two length, that equal to increasing these two lengths, means the total length, change in length is equal to x1 plus x3 plus AD plus BC. So is equal to L1, right? So now x1 you know, acceleration A1 plus A3. These two are negatives, decreasing. This is positive, that is equal to 2 into A of the pulley. So this is coming into a shortcut method for movable pulley. Method 5, shortcut method. So pulley. So these two. So these two have same direction like pulley. Therefore, x of the pulley is equal to x of AD plus x of BC by 2. X of BC is equal to x1. X of AD is equal to x3, right? x1 plus x3 by 2 is equal to x of the pulley. Therefore, 2x of the pulley is equal to x1 plus x2. So 2 into x of the pulley is equal to A2, that is equal to A1 plus A2. So these are the methods to write the constraints equations for different diagram in tension method, displacement method, and segment method, and motion of the points on pulley, displacement of the points on pulley, and shortcut method. So these methods. So thank you. I'll give the explanations in next video.